Hello everyone. In this section, I will share with you how to solve the second-order non-homogeneous linear differential equation with constant coefficient using variation of parameter. Okay, in order to solve the second-order non-homogeneous linear differential equation with constant coefficient, first of all, we need to know what is the constant coefficient. This is the equation, okay, the second-order non-homogeneous linear differential equation. So a constant coefficient means that you have the constant A, B, and C. ABC is a constant coefficient. Okay? Okay, and we name it as a variation of parameter. Here is the procedure to solve the question, to solve the problem using the variation of parameter. First of all, we need to obtain the A. A is a constant for the y double prime. Okay, this is the A. A is a constant for y double prime. So find the A and fx. Fx is the non-homogeneous value, so fx. Or second, then find the yc for the corresponding homogeneous equation. Then we assume the yc equal to y1 plus y2. Then the third step is to find the Rankine W. W is y1, y2, y prime 1, and y prime 2. Then find the u and v. This is we assume u is like this and v is like this. And next we find the general solution. Y equal to uv1 plus vy2. uy1 plus vy2. Okay, now let's look at the example 2.11. Solve the y double prime plus y equal to 2 sine x by using variation of parameter method. Show that the solution is y equal to a cos x plus b sine x minus x cos x. Okay. So first of all, if you look at the step, okay, step 1 is obtain the A and fx. This means that obtain A and fx, and the A is equal to 1 because of the y double prime, the constant here is 1, okay, and the fx is equal to 2 sine x, okay, this value, we take this value, so 2 sine x. And then step 2, we need to find the yc, the complementary function. So for the corresponding homogeneous equation, and let the yc equal to y1 plus y2. Okay, we need to let the y1 plus yc equal to y1 plus y2. Okay, so based on the equation given, y double prime plus y, we assume it is homogeneous. So from here we get m squared plus 1 equal to 0 is homogeneous. So we find the root. The m is equal to minus 1. So it's plus minus I is imaginary. So from here, it's the imaginary. We know that it's a case 3, right? It's a case 3. It's a complex. So we know that the yc is a cos x plus b sine x. Okay? So remember, it's a complex. So you have the exponent exponent x, okay, exponent x, and then multiply with a cos beta x plus b sine beta x. Since the alpha plus beta I, the alpha is 0, okay, alpha is 0, so you get the exponent 0, you get 1. So a cos beta x, beta is 1. So a cos beta x plus b sine beta x. Okay, Then from here, we assume the y1 and y2. So this is y1 and this is y2. y1 equal to cos x and y2 equal to sin x. Okay. And the third step, okay, based on the procedure here, the third step is we need to find the Rankine. That is W equal to y1, y2, y1 prime, y2 prime. Okay. As you know, the y1 is the cos x. And y2 is the sin x. Okay. The sin x. Oh, sorry, it's the sin x. All right. So based on this W, you get the y1 and y2, we get it from the previous, from the step 2. And y1 prime, you need to find the y1 prime. y1 prime from the y1. So differentiate the cos, you get negative sin x. And differentiate sin, we get cos x. So this is equivalent to this one will multiply minus with this one minus. Okay, so cos x times with cos x, you've got cos square x plus, okay, as supposedly it's minus. Okay, supposedly it's minus with sine times with sine, you get sine square x. So you will get positive. So cos square x plus sine square x. So equal to what? This will equal to 1 because of the identity. Okay, identity said cos square x plus sine square x will equal to 1. Okay, so step number 3 finished. Then we go to step number 4. You need to find the u and v. So u using this formula and v using this formula. Okay, so find u and v. U equal to negative integrate y2 fx over aw dx plus a. So y2 from step number 2, we know that y2 is sin x. And a is 1 from the step 1. So we just substitute the value. y2 is sin x. fx is from the question. Fx from the question, that is 2 sin x. Okay, a is 1. So you have 2 sin x. A is 1, w also 1. Then dx plus a. So we can take out this 2, you get negative 2, integrate. Sine times sine, you get sine square x dx plus a. So again, we're using the identity. Sine square x equivalent to 1 minus cos 2x divided by 2. All right. So you have -2 integrate, we substitute this value with this one. So 1 minus cos 2x divided by 2. Then dx plus a. So this one we can cancel. You get -1 minus cos 2x dx plus a. Okay, then integrate. So you integrate the x, integrate the 1 dx, you get x. Integrate the cos 2x, you get positive, right? So you get sine 2x divided by 2 plus with a equal to, so equal to next we find the v equal to integrate y1 fx divided by aw dx plus b. Okay, so y1 we get is cos x, fx is 2 sine x. 1 is, a is 1, w also 1. So we integrate by substituting. We assume the u as sine x. Assume the u equal to sine x. Then du dx equal to cos x. Okay. So now this one we can take out. This is a constant. So 2 cos x. Okay, sine x we assume as a u. Okay. It's a u. So, and then dx is du over cos x. So du over cos x. This will equivalent to 2 cos x. Oh no, cos x we can cancel out. We don't have this. So it's a u, integrate u du. So integrate u, you will get u squared over 2 plus b. So now we get 2. The u is referred to the sine x. So sine square x over 2. This one can cancel out. So we get sine square x plus b. This is step 5. We obtain the general solution using y equal to u y1 plus v y2. General solution. y equal to uy1 plus vy2. So this is equal to u, this is u, okay? This is the u, okay? And this is the v. So u is negative x plus sine 2x divided by 2 plus a, okay? Negative x. Excuse me, no sound. By using variation of parameter. Okay, in order to solve this, first of all, you must know how to find the a. A is the constant from the y double prime, that is 1. And the fx is 3 exponent negative x. Ln x. Oh, my question is I have left out another ln x, okay. And then step number 2, find the yc. Okay, and assume the yc equal to y1 plus y2. Okay, from this differential equation, we know that the m squared plus 2m plus 1 equal to 0. Assume is a homogeneous when you want to find the yc. Okay, so now you get m equal to minus 1 and m also equal to minus 1. This means that the root are the same. So what? Yes, it's a case 2. 2 real and equal root. M1 equal to M2. And then your general solution will be A plus BX exponent MX. So now your YC equal to A plus BX exponent MX. Exponent M is negative 1x, so it's negative x. So now from here, we can know that y1, okay, this one is a exponent negative x plus bx exponent negative x. So y1 equal to exponent negative x, and then y2 is x exponent negative x. Okay, the third step is to find the w. W is equal to y1, y2, y1 prime, y2 prime. So y1 is exponent negative x, y2 prime is x exponent negative x. Okay, so now y1 prime is differentiate the y1. You get negative exponent negative x. And then for the y2, okay, so your uv prime plus vu prime. So x negative x plus vu prime. V is exponent negative x. U prime is 1. Okay, so this is the answer. So this one multiply and then minus this one. So you get x, negative x, exponent negative x. Okay. Oh, okay, it's negative 2x. X, a negative x, this is exponent, so exponent exponent negative 2x. And then plus with exponent negative 2x. Okay, because this one multiply with this whole thing. And then minus. Minus, here you got minus, so it's a plus. Then exponent x, negative 2x. So this will equivalent to, this one can cancel out, you left exponent negative 2x. Okay, now step number 4. Find the u and v. U is equal to negative integrate y2 fx divided by aw dx plus a. So this will equal to y2. Okay, what is your y2? y2 is x exponent negative x. So x exponent negative x. And then fx is from the question, that is 3x. W is, what is the value of w? Is exponent negative x, negative 2x. Exponent negative 2x. So 3 is a constant, so you take it out. So negative 3 x ln x and then you have exponent x as this one, and this one all cancel out. So you left the x and ln x dx plus a. So this one you need to integration by part. By integration by parts. So you assume the u equal to ln x. So this is, you assume is a u. Okay, so du dx is 1, 2.我要你的声音比较大声，我要这样子。 Okay, so we follow the formula. Okay, let me share with you the formula. That is integrate x ln x dx is uv minus integrate vu prime. So this one, u is ln x, v is x squared divided by 2, minus integrate v is x squared divided by 2, u prime is 1 over x dx. So this will equivalent to x squared over 2 ln x minus this one. This part you are left integrate x over 2, so dx, and then you integrate, you will get x squared divided by 4, value of u. So u equal to -3. Okay, -3 x squared divided by 2. So we take all the value here. Ln x plus 3 over 4 x squared, the value of u. Next, we would like to find for the v, and v, the formula of v is y1 fx divided by aw dx plus b. So y1 we get x ln x. So we get 3x ln x minus x. So the answer will be 3x ln x minus 3x plus b. So last, a boy, if you want to talk, you go outside.